Hello, everyone, and welcome to today's webinar at Koç University. My name is Melissa Abache. I work in the international admissions team, and I'm very excited about today's webinar because we're going to be talking about our newly established Koç University Bankası Artificial Intelligence Laboratory. We know that some of you might be sharing for some of the ground rules again as we are doing the presentation. So the idea for today is that we have a good and productive webinar. We're going to share some ground rules to begin with. So please know that you are all automatically muted. We're not going to be using the hand raising feature for today. So please ask your questions using the Q&A box, the icon that you see on your screens, and you can start typing your questions as we progress during the presentation. We will be answering all of your questions at the end of the presentation. So make sure you make your notes as you're hearing from each of our professors if you have specific questions to then type. The webinar is currently being recorded. And we are going to send you that webinar recording because you have registered to participate today, one day after. We're scheduled to last for about 2 hours, including the Q&A. If we need to take a bit longer, we'll do, but we're gonna try to keep it on time, okay? So thank you very much, everyone, for joining. We have lots of people joining today, so we're very thankful for you to taking the time to hear about our new exciting center. I will now talk about what we are going to be talking about today. So we will have a very brief overview of Koç University, which I will present to you, especially for those of you who are joining us from outside of Turkey and may not be that familiar with our university. Then I will ask Professor Deniz Yüret, who is the founding director of the AI Lab, to give us an overview of that lab and also talk about the fellowships that we are now offering to talented master and PhD students from Turkey and outside of Turkey. And then the biggest part of today and what we are very excited about is that you can get to meet the faculty members who are part of this center, and they will give a brief introduction about their groups and about the projects that they're working in. And then based on that, you can ask them further questions. So at the end, we will have plenty of time to answer your questions, as I said. The idea for today is that we focus on research and projects and ideas and topics. So if you have admission specific questions in terms of what documents are required, GPA, TOEFL, GRE, all of this, what I please ask you to do is to watch our Graduate School of Sciences and Engineering webinar, which is now in our YouTube channel. At the end of the presentation, we will have a slide in which you can see the YouTube channel address, and you will also receive an email with this information. And of course, you can also check the Graduate School of Sciences and Engineering website, where you can see all of that information and step by step. Okay, so, and more people, I see more people keep joining in. Thank you for joining us today. Just to recap very briefly, we are recording the webinar. We're not using the raise hand feature. Please type your questions only on the Q&A box, not on the chat box, okay? So for those of you unfamiliar with Koç University, first thing to say is that we are located in Istanbul, research-intensive university that was set up 26 years ago. So we're quite young within the context of Turkey, where we have universities that are over 400 years. But in that short amount of time, we have become a center of excellence that it's providing world-class education and creating impact through the research that our professors and our researchers do together. I really like this picture because it also shows our campus, which is in a beautiful setting in the northwest part of Istanbul with the Black Sea behind us. And rather than me telling you a lot of details about the campus or what facilities it has, I would encourage you to also check on our YouTube channel, our aerial campus tour, in which you can see everything. And there's a lot of videos which are done by our students describing the different facilities that they have. One thing to also emphasize is that we are a small university and we want to keep it that way. So what you get here in terms of education, it's a very dedicated one-on-one small student faculty ratio approach to education and to supervision as a graduate student. We have a lot of benefits for graduate students, both Turkish and international. We will talk about some of those which are specific to the artificial intelligence lab, but these are the things that we want you to know. We're currently now ranked in the top 3 universities in Turkey and also within the region. We're amongst the best and we're looking for the best as well. Thank you so much for joining today. And I'm now going to talk about very brief, again, because we're talking about talent here. This is just a sample, a very small sample. We have, for like longer lists about this, of some of the places where our Graduate School of Sciences and Engineering alumni have found positions after graduation. So this is a mix of students who have completed their master's or their PhD degrees in our university in departments such as computer engineering, computational sciences, mechanical engineering, electrical and electronics engineering. And they, with that degree and with the training that they have received from our professors, it's very easy for them to find good positions at the most prestigious universities, especially in the US, in Europe, here in Turkey as well, and in industry, not only in Turkey, but also outside of Turkey. So with that, I would like to now invite Professor Denis Juret, who is here with us today, to open his microphone. I will close mine and introduce himself and the laboratory.
Thank you, Melissa. Thank you all the participants for joining us. I'm going to talk briefly about our Koç University İşbank AI Lab. We were established this year with a generous contribution from İşbank. Our aims are to become a center of excellence in AI research, education, and industry cooperation. We have more than a dozen core AI faculty and 20 plus associated faculty in different cross-disciplinary areas that are using AI in their work. And our biggest strength is our personnel, researchers, graduate students. We have one of the highest publications per faculty records in Turkey. And we do have strong relationships with industry and alumni as well. So having said this, most of our power comes from our graduate students and postdocs and researchers. And one of the primary goals of our center is going to be to provide a very good research environment for all the talented young people interested in AI. So for this purpose, we have established an AI fellowship program, which I will talk about next. So when we asked ourselves what are the things that a young researcher needs, we came up with this package. We're offering a very competitive starting salary for master's and PhD students, full tuition waiver. We're going to expect everyone to start doing research from the first semester they come here. The main goal is research in our university. And to encourage that even further, after your first qualified publication, we're going to offer a performance bonus. Travel can sometimes be a problem for financial reasons, so we're going to give full support to any student that can actually publish in a conference at the top of their field. In terms of computation, we're making a big investment, and we're going to have one of the largest GPU clusters in the region, and this and the laptops we provide our graduate students will aid their research. Other standard benefits apply: housing for students, private health insurance, subsidy for meals, etc. So in order to apply, you can go to the apply.ku.edu.tr website. The deadline for application for this round is May 30th, and we're hoping that to see some of you apply for the MS and PhD in computer science and engineering programs. This is sort of a description of what kind of students we're looking for. I'm going to just summarize it in 3 points. I think that in order to be a successful researcher in AI, the most important thing is number 1, motivation, and then English, math, and programming background. So if you have a strong background on these 3 things from your undergraduate or master's degree, I think you'd have a good chance of becoming a strong researcher in the AI field. Next, I want to talk a bit about the field itself. For those of you who may not have taken classes or read up much about artificial intelligence, I can summarize the definition of AI as analysis and synthesis of activities that require intelligence. There are 2 perspectives that we can look at AI, the scientific perspective and the technological perspective. Melissa? Thank you. In the scientific perspective, what we're asking is basically, how do intelligent systems, natural intelligent systems work? We know that all intelligent systems have systems of perception, systems for learning, thinking, and action. And by analyzing and modeling these abilities, we attack problems like how images and sounds are processed, how learning happens, how planning and language production understanding happens, how do we actually convert our plans to motions, etc. So this is the scientific perspective in AI. On the other hand, technological perspective says we take the answers to these questions and then we create products that are useful in real life. And these products have been entering our life more and more in the last 5-10 years. I'm sure you've all used the fruits of language processing technology in Google Translate and personal digital assistants like Siri. Image processing is becoming more and more important in medical and security type areas. Every time you get a recommendation on an online shopping center, you're using AI recommendation technology. Companies are using sentiment analysis to gauge their customers' reactions. Self-driving cars are coming. Robotics is going to become more and more a part of our lives. Next, please. So without further ado, what I want to do now is to let our core AI faculty introduce themselves. So I'll pass the microphone to Melissa.
Great. Thank you very much, Professor Denise, for that great introduction. So just a quick reminder for those of you who may have joined us right we had started. We are now going to be introducing each of the Koç University Artificial Intelligence Lab faculty members. You can type your questions on the Q&A box on your screens. We have a separate webinar and it's already on our YouTube channel with regards to the process of admission to our master and PhD programs, including computer science and engineering. So we are checking now some of your questions. They're related to admission. So we are going to focus today more on questions which are about the projects and the work and your research interests and to see if they're aligned with those of the faculty members. For those specific questions about requirements and such as English proficiency, GRE or others, please do watch that other webinar and also check our website. So without further ado, I would like to first invite Professor Alper Erdoğan to open his camera, and I will stop sharing my screen so that he can share his, and to talk about his research.
So I'd like to welcome you all. I'm Alper Erdoğan from Electrical Engineering Department. I'm also the lead of Advanced Signal Processing and Communications Group. We have some master and PhD students in our group working on projects related to signal processing, machine learning, and communications. And the main focus of our research group is algorithms for learning. So at the center of our efforts is the design of such machine learning algorithms, where we typically use the normative approach where the optimization settings are at the center of this design process. And once we actually design these algorithms, we implement them in environments like MATLAB, Python, and Julia to test them. But in addition to the implementation, we also do the theoretical analysis and characterization of these algorithms, as well as the algorithms derived by other people. And so some of our research topics, among many, we are mainly concentrated on the unsupervised algorithms, and we use matrix factorization methods. And also we are interested in the applications of machine learning in the communications field. We have compressed training framework for massive MIMO systems. And we are also very interested in the biologically plausible and principled neural networks obtained from optimizations. And such networks have applications in computational neuroscience as well as neuromorphic computing. Just to give you a flavor, this is an example of a biologically plausible neural network with feed-forward feedback and top-down connections like brain, which separates mixtures of images, just learning from these 4 images only. And after the convergence, you can see the original source images. Thanks for attending. So that's all for now. See you.
Thank you very much, Professor Alper Erdoğan, for your introduction of your research group. I would like now to invite Professor Attila Gürsoy to then introduce himself and talk about his work at his group.
Hello, everybody. I'm Attila Gürsoy, professor in Computer Science Department. I also co-direct COSBI Lab, Computational Systems Biology Lab with Professor Özlem Keskin from Chemical and Biological Engineering. My research area is an example of interdisciplinary research in the intersection of computer science, molecular biology, chemical and biological engineering, medicine. So we are interested in developing methods and tools using biological data to answer some questions in biology. Oops, sorry, go to the next slide. So biology is increasingly becoming a data-driven science, and the computational approaches reach all aspects of medicine and biology, from understanding disease and to developing therapies. So we are going through a digital revolution, Internet of Things, big data, cloud, and the next revolution will be in medicine in the age of AI. We are particularly interested in protein-protein interactions because protein interactions are at the center of the processes in the cell. All the communication and signaling handled by protein-protein interactions. Any malfunctioning protein results in errors in signaling, which causes diseases such as cancer. So we focus on precision medicine and questions like, if a timely question, for example, why some COVID-19 patients experience loss of smell and why some people experience kidney problems, for example, or why breast cancer metastasizes lung or brain, depending on the person. So we develop methods that use data, huge data by genome, proteome, transcriptome, petabytes of data to help answering these questions. And I'm skipping the steps. And my final slide is where our tools are widely used, well cited, and we want to incorporate more advanced methods in machine learning. So thanks for listening. I'll be waiting for your answers.
Thank you very much, Professor Attila Gürsoy, for that introduction.
And
I would like now. I would like now to invite Assistant Professor Barış Akgün to introduce himself and the work that he is doing.
Hello, everybody. As soon as I can share my screen, I will. Somebody's still sharing, I think. Attila Hocam. Okay, thank you. Oops. Okay. So, my name is Barış Akgün. I'm from the Computer Engineering Department at Koç. I mainly work with robots. I'm interested in the intersection of robots, AI, machine learning, interaction, etc. Specifically, I like autonomous robots, robots that interact with people, robots that learn from people, such that, you know, when you go out and buy a robot at your house, you can easily train it yourself. I also do some applied machine learning work, but I mainly focus on robotics. So one example I work with robots, it's learning coupled action and perception from human demonstrations. As such, the robot knows how to execute a skill. Here you can see some simple skills like closing a box and pouring. At the same time, know whether the robot is, whether it is successful or not. So this is very important. You know, everything might fail. It's important to know whether you fail or not. In addition to this, we can utilize this information to adapt and get better. Here's another example with another robot. Here, the human gave the robot 2 demonstrations of opening the box. It didn't learn very well, but then through trial and error, it improves itself. In this work, we did reward learning. Basically, robot learned how a successful opening looks like, and it tried to replicate it with reinforcement learning. As you see, as it tries and improves itself, the reward it gets on the bottom right-hand corner increases. And the way the robot sees the world is through a depth camera. You can see it in top right-hand corner as well. Of course, when we have these robots, they're going to be next to us and we want them to behave in an understandable manner. We can use reinforcement learning techniques to train our robots to generate communicative motion. Here, the robot is reaching one of the 2 objects and the human is guessing which object the robot is reaching towards. If the human guesses correctly, it gets a positive reward. And this way we can teach the robot on how to behave. So my focus is again on getting robots next to people, them collaborate with people, learn from people, and in general be useful for others. And we heavily use machine learning, computer vision, you know, control concepts. It's a highly interdisciplinary work. So if you enjoy that, I'm sure you'll enjoy this as well. And with that, my time. Thanks for listening.
Thank you very much, Professor Barish, for your illustrations of your work that you're doing. I would like now to invite Professor Çağatay Başdoğan to talk to us about himself and his group and the research that he's doing as well.
Okay, hi everybody. This is Çağatay Başdoğan. I'm a faculty member in Mechanical Engineering Department and also have an appointment in Computational Science and Engineering program. And our research is at the intersection of mechanical engineering and computer science. And I also direct the research in robotics and mechatronics laboratory at Koç University. Our focus, of course, robotics and mechatronics is a very large area, and our focus is in a particular area called haptics, sense of touch. So as a laboratory, we're interested in how humans touch and feel objects, how we can transfer this information to the machines, such as robots, and also how we can regulate the communication, haptic communication between the robots and humans. I like to share my screen and show you one of the projects that we are currently working. Is that working now? Can you see my screen?
Yes, we can, Professor.
Okay. Great. So this is a project that we're working. It's related to the physical human-robot interaction. This type of robots that we're using that are interacting with humans, we call them cobots, collaborative robots. In here, the goal is to do a collaborative drilling with the robot. You can see the orange piece is is the cobot, and user is utilizing an augmented reality interface to learn the details of the task and interacting with the robot. So the main goal of this project, for example, understanding human intention of what he wants to or she wants to do so that you can program the robot accordingly. So if you're interested in this type of projects, which is at the intersection of robotics, mechatronics, virtual reality, and augmented reality, with some applications in machine learning and deep learning, please visit our website or personally contact me. Thank you very much.
Thank you very much. I apologize, a neighbor, we're all working from home and I have a neighbor banging on the wall right now. But now I would like to invite Professor Denise Uret who you have met already, to talk in more detail about his specific work and his group and their projects.
Thank you, Melissa. Can you see my screen?
Yes, we can, Professor.
Okay, so I just want to show you 3 little videos about my research. So these days we generally focus on grounded language understanding and learning. In this first video, we're in a virtual environment and a human types some expressions to guide the video for a certain navigation, and the computer basically is supposed to follow this navigation. When the system first starts, there is no knowledge of language, so every word and every meaning is learned from experience, from examples created by humans. So we have a bunch of students creating these examples, and the computer watches them and eventually figures out what walk means, stop means, etc. In the second video, this time, instead of using the perception and language in order to guide action, we're trying to do perception to language directly. So a camera is watching us play with a ball, and the computer is going to narrate what we're doing as we're doing it. So finally, the last example I want to show you is the opposite of this. In this case, we basically give the computer a natural language description, and we want it to imagine what that description refers to. So in the first example, it says a monkey is in the room on the table, and the computer is supposed to generate a corresponding scene from only the description. A second example says a man stands next to the car in front of the house, and the computer basically finds the correct models and arranges them in the configuration that is compatible with the description. Now, in all these examples, you'll notice that the focus is on connecting language with the world and words with what they actually refer to. Some of the technologies I mentioned before, like Siri and machine translation, unfortunately do not have any real understanding of language. They work by just pattern matching language, and they don't actually understand the words. The long-term goal of our group is to create AI systems that can really learn and understand language. Thank you.
Thank you very much for showing us those videos as well, Professor Denise Juret. I would like now to invite Assistant Professor Didem Unat to introduce herself and the work that they are doing at her lab.
Okay. I think you can see my screen now. Is that right?
Yes, we can.
Okay. Hi, everyone. This is Didem Unat. I lead a parallel computing group at Koç University. Our research focuses on developing system software for AI. This is an interesting area of research, and its popularity is actually increasing because many companies are looking for people who know both the computer systems and AI algorithms and frameworks. So it's a good intersection between the two domains. What do we do more specifically? We study the scalability and parallelization of deep learning frameworks on large-scale systems like data centers or supercomputers. It is important to study such areas because training time of neural networks can be in the order of days, even weeks. So we focus on, our goal is to improve the performance and optimize such frameworks. In other words, we are not the users, but the developers of deep learning frameworks such as TensorFlow or PyTorch. I would like to mention that we have international collaborators all around the world, and my students have a chance to visit these collaborators and do summer internships. We have an ongoing project with ICE Japan and another project with Berkeley Lab in the US on quantum computing. And we are also starting a new project with GraphCore, which is one of the most innovative companies which develops specialized hardware for AI. And my group is focusing on developing software solutions, programming solutions for such an emerging novel architectures. Well, if you would like to know more about our group, you can visit parkourlab.com, which is our group website, or contact me via email. You can also watch my TEDx talk on YouTube, which is on supercomputing. Thank you very much. That's all from me.
Thank you very much, Professor Didemonat. I do apologize. There's a lot of noise, so ignore my background noise. I would like now to invite Professor Engin Ersin to introduce himself and his areas of research.
Okay, I think I'm able to share my screen. Hello, everybody. I'm Engin Ersin. I'm with Koç University since 2001. And before that, after my postdoc at UCSP, I was in Lucent Technologies, and I got my degrees from Bilkent University. My research interests include speech signal processing, multimedia signal processing, human-computer interaction, and machine learning in general. In multimedia signal processing, what we study is the systems of audio, video, speech, and motion in our research group. And I'm going to present some examples of what we did. We work on speech-driven upper body and head animation systems that we learn the relationship of speech, prosody, intonation, and the body motion, and try to synthesize motion out of speech. And we also consider multimodal affective interactions, especially for the analysis of interaction dynamics. And we have a motion capture system for this purpose in our lab. And human-computer interaction is yet another active research area that we are working on. Especially, we are working on engagement monitoring and back-channel synthesis so that we can maximize engagement. Effective facial feature synthesis is yet another interesting area for me, which we work in deep domain adaptation models for transfer learning from neutral domain to effective domain. Vocal tract landmark detection and tracking in real-time MRI systems captures the dynamics of speech production, and over there, vocal tract boundary detection is a typical problem, and we develop deep temporal regression networks for this purpose. If you have further questions, you can go ahead and type them in the question and answer session. That's all for me.
Thank you very much, Professor Engin. That was very interesting to watch. I would like now to invite Assistant Professor Fatma Güney to introduce herself and her work. Okay, I think we have a video ready for this.
Hello everyone, my name is Fatma, and I'm going to introduce myself and my research now. I graduated from Computer Science Department of Bilkent University in 2010. After my master's at Boğaziçi, in 2013, I moved to Germany to do my PhD at Max Planck Institute. Then after a brief postdoc at BGG, I started as an assistant prof here at Koç University in September. I am honored to have received 2 individual fellowships by TÜBİTAK and European Commission in my first year at Koç. Here is a summary of what I do in my research. In fact, what we all do at AI Lab. We teach machines to do specific things for us. We do that by not giving very specific instructions to the machines, but instead by feeding the data and letting the machine learn from the data. Specifically, I work on teaching machines to see, computer vision. More specifically, my area of research is called autonomous vision, which we define as computer vision for autonomous driving. In autonomous vision, we are particularly interested in outdoor scene understanding for safe navigation of autonomous vehicles. Here are some example problems that we work on in autonomous vision: detecting objects in the traffic, assigning pixels a semantic label, depth estimation by reasoning how far the objects and surfaces are located from the camera, as well as by building complex 3D models of the environment. We also work on motion estimation by tracking pixels or objects on the image. We have some available positions. Please get in touch if you're interested. Here is a depiction of my goals for the next few years in autonomous vision. We can detect and track all the objects in the scene. Even more interestingly, we can reason about the intentions of these objects, their next moves, by considering all the dynamics of the scene. Thank you very much for listening.
Thank you very much, Professor Fatma, for that introduction. I will now invite Professor Metin Sezgin to introduce himself and his areas of work.
Okay, thank you, Melissa. I'm Metin Sezgin. I hope you see my slides. I lead the Intelligent User Interfaces group at Koç University. A little bit of history. I completed my master's and PhD degrees at MIT, then moved to Koç University after a brief postdoc at the University of Cambridge. My research is funded by global and, let's see, it's not working. My slides, are they moving? Okay, my research is funded by local and international funds, and my main areas of expertise are intelligent user interfaces, machine learning, and multimodal interfaces. I work mainly in the intersection of three areas: HCI, psychology, and machine learning. So let me give you examples of past and current work which fits into this intersection. On the intelligent user interfaces front, we combine technologies from gesture recognition, speech recognition, emotion recognition, etc. For example, to do multimedia retrieval, rehabilitation of kids with autism, gaze-based intent recognition. We also work with hardware. We build smart hardware like smart stylus. We work with robots, affective robots, and we also work on human-robot interaction. On the more machine learning related side of our work, we work on learning visual attributes from images and text data. We concentrate on learning, machine learning problems such as learning from few examples, active learning, segmentation problems, explainable AI, and also use machine learning for retrieval and multimedia search. That more or less summarizes my existing and past work. I'd like to end with alumni profile. As you see, our alumni go to top places and they go there by conducting state-of-the-art research here at the Intelligent User Interfaces group in the AI lab. Thank you.
Thank you very much, Professor Metin, for your introduction. I will now invite Professor Öznur Özkasap to introduce her work. I will share my screen very briefly. You just bear with me for a second. Yes, Professor.
Thank you.
I will now play the video, okay?
Hi, everyone. My name is Öznur Özkasap. I am a professor of computer engineering at Koç University. I am leading the Distributed Systems and Reliable Networks research group. Here you'll see some of my recent academic work. We conduct research projects in areas ranging from intelligent, distributed, and network protocols, energy efficiency in distributed systems, software-defined networks, ad hoc networks, peer-to-peer blockchain-based systems. With the ever-increasing amount of network and systems data, machine learning techniques play a significant role in discovering knowledge from the data. One of our sample projects is about machine learning for software-defined networks, where we propose a novel ML framework for energy-efficient network routing. In the Blockchain-Assisted Intelligence Services project, our objective is to develop ML methods for blockchain-enabled peer-to-peer solutions for smart city. In the context of intelligent edge computing, we work on novel algorithms to enable sensor network solutions at the edge. In this slide, you see our project funding sources and the institutions that we perform joint work. For our research publication details and further information, you can check the website. Here are some of our DISNet Lab graduates and their current positions. For your questions, please feel free to contact us by email. Thank you.
Okay, so we had an introduction from Professor Öznur, and you will be able to also ask more questions during the Q&A part of today's webinar. So now I would like to invite Professor Yücel Yemez to introduce himself and his research as well by sharing his screen.
Hello, I'm going to share my screen first. I hope you all see my screen.
Yes, we can.
Okay, thank you, Melissa. So hello everyone. I'm first a short bio. I'm Yücel Yemez. I'm a professor in the computer engineering department, and I got my PhD from from Koç University in 1997. Then I was a postdoc in Telecom Paris, known also as University at that time. And in 2000, I joined actually as a faculty Koç University, right? So I do research on various fields, various AI-related fields, including computer vision, human-computer interaction, multimedia signal processing, effective computing, and computer graphics. But my recent focus is more on computer vision and human-computer interaction, and on which I'm going to elaborate a bit more. So computer vision is an integral part of artificial intelligence. And the basic problem here is image understanding. And the images that we try to understand here can be video with a temporal dimension, or can be three-dimensional with a depth component. And I work on various aspects of this image understanding problem, including object detection, right, recognition, tracking, and then finding relationships between these objects detected, and then hopefully end up with some description and a bit of understanding, which is a challenging problem actually in computer vision. And to address this challenge, image understanding challenge, we use all sorts of deep learning methods, including CNNs, RNNs, graph neural nets, transformers, etc. And I also teach computer vision with deep learning course at Koç. Right. So, and for human-computer interaction, here is a typical example of what I do, what we do actually as research in the lab. And on this, I intensively collaborate with other professors from our lab, Engin Erzin and Metin Sezgin specifically. And here you see our social conversational robot, Furhat, right, in interaction with one of our graduate students. And we have a robotic head in our lab, and we try using human-to-human interaction data so that it learns how to behave more humanly during interactions. And for example, it can laugh, smile, and even make jokes, right? And there are very interesting problems that we work on around robots. And address these problems, we use deep reinforcement learning, for example, as well as methods for machine learning, effective computing, and signal processing. So we can take more information if you want from our website. Thank you.
Thank you very much, Professor Yücel, for that introduction. Now, last but not least, I would like to invite Assistant Professor Zafer Doğan to introduce himself and the work that he and his group are doing at our university.
Hello, everyone. This is Zafer Doğan. I'm an assistant professor at the Electrical and Electronics Engineering Department of Koç University, and I mainly work on the interpretability and explainability of artificial learning models. Here is a brief bio about myself. I received my undergraduate degree in 2009 from the Middle East Technical University. Then I moved to Switzerland for my master's and PhD degrees in electrical and electronics engineering, where the main focus was on data representations, sparse signal representations, and such. After getting my PhD degree, I worked for 1 year at the campus Biotech in Geneva as a postdoc fellow. And before joining to Koç University, I was a postdoctoral researcher at Harvard, at the School of Engineering and Applied Sciences. My research is at the intersection of three main fields, which are inverse problems, optimizations, and machine learning. And in such, the key idea here is to develop like convex and non-convex efficient solvers, where we can develop also like performance metrics. And in the particular case of machine learning and AI, my current focus is on developing some methods to explain such tools. So in the core of this idea, we are basically trying to find out a solution for a non-convex optimization function, which might look like rather drastic, where we could have like multiple and numerous behaviors of local minima. And the challenges are like they are non-convex, and dimensionality wise they provide issues. But luckily, simple methods, although not fully understood, works well in practice. And my goals are twofold in this setting, where to develop like tractable dynamics in learning algorithms for non-convex optimization, and by getting this insight from the theory, having like a constant development in terms of deep learning and machine learning applications. Some key concepts that I use a lot in my research is like scaling limit analysis of Markov chains, mean field theory, and the propagation of chaos and exchangeability ideas. And this can be applied on GAN training, performance limits of EDSR and UDSR. So if you're interested in any of these topics, please feel free to get in touch, and thank you for listening.
Okay. Thank you very much, Professor Zafer Doğan, for your introduction. So now we have done a full round of introductions of all of our faculty members. I'm going to share my screen now to go back to our presentation. If you please bear with me for a second. Okay. So the idea, just to recap for those of you who might have joined us a bit later, we kindly ask you to please type your questions only on the Q&A box so that we are able to see them and have a record of them for later if we want to answer other questions. I'm manually dismissing some questions right now, which are more to do with, oops, sorry about that. Okay, so that's my neighbor doing work in the middle of the afternoon. So we are trying to, let me start my video as well. We are trying to answer your questions. I do apologize for the interruption. So what we're going to do is we're going to start reading the questions. I will ask Professor Metin Sezgin to help me out here. We are going to read the questions, and then our professors who are with us today can jump in and answer those questions. I might need to mute myself, and I will ask Professor Metin to start because I guess he doesn't have a noisy neighbor right now.
Okay. Thank you, Melissa. I went through the questions and tried to filter some. So I will read them, rephrase them for our faculty to answer. The faculty can address the questions as they wish. So to start with, there are many questions about admissions criteria, whether or not certain tests are required, or whether certain scores are sufficient, etc. We will not be taking such questions today because information related to that is on the graduate school's website. So we ask you to check out the graduate school's website for that. I will try to share with you questions that relate to research. So let me read one out, and then maybe one of our faculty members can take it on to answer. A student asks, I'm a graduate of electrical and electronics department, and I want to pursue my studies in computer vision. What set of skills, prior knowledge is expected from a potential candidate? Okay, so who would like to take this on?
One of our computer vision faculty would be better to answer this, but
Fatma or Yücel, you want to answer this question?
Yeah. Okay. So there's no problem. I mean, if you are a graduate of electrical and electronics engineering department, you're welcome. So it's good if you have some background on the problem, computer vision, I mean. So you might need some background on machine learning, and also, of course, some background on math, which you already have, I guess, and of course, a bit of good programming skills. That might be maybe only problem, but that's also a very person-specific issue. So if you feel good, you know, in terms of programming, could be Python, could be anything. If you think that you can solve, you know, problems at ease, you know, maybe using MATLAB. So MATLAB is not always sufficient, but it's, if you're good at it, you can learn other things. But at least usually we require some other programming skills, other beyond MATLAB, which might be C, C++, or Python at least, right?
May I also add that
Yeah.
please have a look at the selective courses in computer science department at your school. Usually it's a good idea to combine selective courses from your department and computer science department if you have plans like that. Some introductory courses on machine learning, computer vision would be a good idea, I think.
Okay, thank you, Yücel Hocam and Fatma Hocam. Let's now move to another question. Actually related to this previous one, says, what sort of expertise is required, and are there tests or entrance exams to measure this expertise? So maybe Deniz Hoca,
I can answer that.
Answer this.
So basically, as I mentioned earlier, the three most important things are your competence in English, math, and programming. So this might come from your classes, or it might come from your own prior work. In order to show these to us, the graduate school asks for certain tests like GRE or ALES. And right now, because of Corona, we're permitting these tests to be taken later, so you can actually apply without your test scores, and you may get a conditional acceptance and be able to take your tests when the situation improves a little bit. Lastly, for the AI fellowship, after you get admitted to get the scholarship, we may actually perform another take-home test / interview to judge your skills in these areas. Thank you.
Okay, thank you, Dr. Yuret. Another question asks, is the application to the AI lab different from an application to the graduate school? So I think there's some confusion here, so it's worth clearing that out. Okay,
so basically you apply to the graduate school and you designate your interest area of interest as an AI-related topic. And you can see the list of AI-related topics on our website, gsse.ku.edu.tr. And you go through the standard application process. So up to that point, there is no difference between a general graduate school application and AI lab application. Only after you go through the application process and the interviews and you get admitted, at the funding phase, there is several different sources of funding. Koç University itself offers certain funding. Professors offer funding from their projects. And finally, the AI Center offers the AI fellowships that I mentioned earlier. So in order to qualify for the AI fellowship, you may have to take some additional steps, like a take-home exam.
Okay, thank you, Dr. Uret. As we're talking about the funding issue, there is a question which might be relevant here. The scholarships, are they funded by as private funds by Koç University, or are they state money? Are they state money? I think there's a concern that there are some work permit related issues for using government money in Turkey. And I would just reply to this myself saying, this is not state money, and we don't foresee any work permit related issues. So international students are welcome to apply. So there is a question on what's expected from students in their first semester. So it says, while it's expected for students to start their research at their first semester, is there enough time for students to refine their own research ideas, or do they start working on ongoing projects?
Each group has a different way of eating their yogurt, as they say. Some professors have fixed projects and problems, and they're actively looking for students that are going to work on those problems. Some professors have a more or less a fair approach, and they actually lead the students to pick the topics that they're interested in, that is of common interest with the advisor. So the exact answer to that question depends on the advisor that you pick. So you should discuss this topic with your potential advisor during the interviews, maybe.
Yeah. Can I add something as well? So some of the students have a clear idea what they want to work on, and they actually come with some project ideas, and we consider those as well. So it's not just up to the professor, but also sometimes up to the student as well, because they, let's say, started working on a project in their master's and they want to have new ideas to continue on PhD. So we, of course, find a middle ground, and both sides are happy at the end, I would say. Yeah.
Also, can I add something? So one good thing with this AI fellowship that we offer actually is that, you know, you're not really constrained with any project work. So regardless of any project limitation or whatever, you are kind of free, of course, with your advisor to define a research topic and work on it. So that also is an opportunity really to define some really very innovative research ideas and pursue them, which otherwise you would not be maybe able to do it when you constrained with some project deadlines, etc. So it's one of them with this AI fellowship that it gives in terms of research, I guess.
Okay, thank you, Dr. Yemez, Dr. Uret, Dr. Unat. Another question. There are competitor institutions, I guess, around the world and in Turkey as well. So a question says, what makes Koç University and your lab unique?
In terms of Koç University, you can just look at our numbers and statistics. So we're a research-oriented university. Our evaluations, our goal is basically to excel at research, and that can be seen with our publication record. And also the number of TÜBİTAK projects and European Union projects and other scientific project funding sources that we utilize. What makes the AI lab unique is that we have this unique opportunity, a very generous resource provided by İşbank to us. And our top priority is to make this an ideal working environment for young researchers. And I think a lot of institutions have similar goals, but they may lack the funding to create that environment for their students. Right now, we do have the resources to achieve it, I believe.
Okay, thank you, Dr. Uret.
Metin,
another question.
Yeah,
sure.
Sorry. Just want to say, I think my neighbor. has stopped now, yeah.
Okay, would you like to take over?
Okay, let's do that. So, there was a question here about which professor is working on AI for health. As an example, chest X-ray classification projects, for example, if any of our professors are working on that type of topic. So if any of our professors are working on artificial intelligence for health applications, maybe they can elaborate on this.
Attila, possibly, and vision people, possibly.
Engin might be actually might talk about this a bit.
Yeah, not specifically chest X-rays, but yes, we have certain collaborations with the medical school, and not only our group, actually, several other groups are in close collaboration. But as far as I know, none of them are on medical imaging. They are more related to data science, and also, for example, in our case, we are working with neurologists for human motion analysis, pathological cases, and their automatic analysis and understanding.
If you do some work with eye doctors on medical images, it's more about developing decision aids using AI and machine learning, like not directly using the output of models, but working on them a little bit more, including some explainability, interpretability methods to tell the doctor, hey, I think this eye has this disease and look at this region, for example. And since, there could be multiple images of the same patient, their left eye, right eye, there are multiple different imaging techniques. We sort of try to combine the information to come up with that. And I know some other people that work on at Koç with medical images as well. So there's some opportunities for that, as Engin Hoca mentioned.
I also want to add, for people who may not know, that Koç actually does have a medical school and a research hospital, and there always are new opportunities for us and the medical department to work together on health-related topics.
Yes, and let me add to that too. Talking about medicine and rehabilitation, I might want to mention this European project that I carried out in my group, where we built smart interfaces to help children with autism. We built interfaces that teach them how to express and recognize emotions, kind of an autism rehabilitation tool. So maybe not necessarily in image processing, or but again, healthcare related.
Yeah, I'd like to actually mention a project that we have regarding EEG-based epilepsy source localization that we are basically jointly doing with the medical medicine department. So we are using EEG data and use unsupervised algorithms to locate the origin of the focal epileptic seizures.
Thank you very much. Yep. I think there is a follow-up question a bit related to that, which is AI for drug discovery, whether the people who want to work on that area, do they need biological background, like training in biology? I guess it's the question. So for professors working on drug discovery and using artificial intelligence, yes, do the candidates, should they have some prior knowledge of biology and life sciences?
Maybe I can comment on that, but Deniz, you are muted if you want to talk.
Sorry, you.
Go ahead.
Oh, so I was just going to say, for any interdisciplinary topic like this, it is not expected that the incoming student know all of the related fields, but students with competitive, quantitative, and computational backgrounds can take additional courses during their degree here to catch up on the field of study. So we do have a chemical and biological engineering department. We do have a medical department. So any extra knowledge needed for the research can be actually gained while they're here.
Okay, thank you, professors. Melissa, I'll take on to read one of the questions. How will the preference of labs be carried out? Do we indicate number of labs we would like to work? How do you, basically, do we apply to labs? Do we apply to faculty members, or do we apply to the graduate school? How does that work? So I guess we were talking here as advisor and leads of different groups. Do people apply to these groups or to the lab or to the graduate school?
Maybe I can answer that question. So in our website, you will see the research areas. I suggest you examine them. And in your application also, you will be selecting 3 choices, 3 preferences. And you can indicate also in your statement of purpose if you're particularly interested in some of the faculty. I will advise not just giving one name, but to use all 3 options to preference to indicate your interest. But any of the faculty may be interested in you and then may want to hold an interview. So it's you don't need to apply just a single lab. It's all open. So you will be evaluated by all faculty if they're interested in you.
Thank you, Professor.
I would just like to add one thing, is that the final choice is always up to the student. If there is more than one group or one faculty interested in working with you, you get to choose which one you work with.
Okay, I have a question here for Professor Denise with regards to that you have talked previously about some hardware infrastructure being established on GPUs or CPUs and computation power. When is it planned to be in use by researchers?
So Didem Hoca can answer this, but all I just want to point out that we do have a cluster right now that is actively working. We're basically planning a large improvement on it by next September. Didem Hoca, if you want to give any details.
We are actually in the process of purchasing it because of this coronavirus. It's delayed a little bit, but we are expecting it will be up and running by September. And it will be one of the biggest computational power in the region. So we are hoping that no one will have issues accessing GPU clusters or computational resources here by September.
In addition to that, to cover any missing capacity, we also will support cloud resources as well. So if the GPUs at school are not enough, the students will get cloud credit to use at Google, Amazon, Microsoft, etc., to access their GPU machines.
Thank you.
There is a question on the robot-based human-computer or human-robot interaction research. It says, how much of the research is related to feedback control systems rather than machine learning? Do you use robots to collect data or do you design them? So not a coherent question, but many questions in this one question. So we can take different parts.
Okay, let me answer, and maybe Professor Baştan also wants to chime in from his perspective. We, at least in my group, we don't directly develop feedback systems. We have policies that you can use as feedback systems. However, we trust the supplied controllers from the robot more. If you think about it, it's more like an hierarchical organization. You generate trajectories that the robot should follow or generate the commands that the robot should follow, but trust the robot's own controllers to follow them, and if that makes sense. We are slowly getting into more torque control, and that requires some amount of feedback ideas, like you need to be stable, and that brings us to the interesting intersection of stable controller learning. How can you enforce that? So we are looking at those, and it's in its infancy. And I guess the second question was whether we design robots or collect data. Sort of like neither. We buy the robot and develop algorithms that work on those robots. Yes, we inevitably collect data, but it's not just for collecting data. It's for actually developing the algorithms and models. I hope that answers your question.
I can maybe add on that. Well, I mean, I mean, since we work on human-robot interaction, physical interaction, obviously we have to develop our own controllers. Like there's something called interaction controller, and then we do develop our controllers. But if the student wants to work on specifically some CS based applications such as machine learning, deep learning applied to the human-robot interaction, then there is of course somebody helps him with the control aspects of the task. So I mean, the student can go both ways, and we also collaborate with some other CS faculty to develop those deep learning, machine learning codes, and one of them is a Barış Akgün, the other one is a Metin Sezgin. So, and could be working with other faculty members as well. So we primarily develop our own controller, but if the student is not interested and he doesn't have a background on that, that's fine. I think there are people in the lab who can help with the control aspects of the problem.
Okay, thank you, Çağatay Hocam, Barış Hocam. And I'd like to just add to that, in the Multimedia Vision Graphics group and in the Intelligent User Interfaces group, we also work with robots. We don't build the robot, but we are mainly interested in programming them for human-robot interaction research. So
there is a
Dr. Başdoğan mentioned joint work of faculty members. So there's a question about whether co-advisorship is possible. And I would just answer this saying yes, and many faculty members actually do co-advise students. And give it to Melissa for her next question.
Okay, thank you. We have a question for the COSB lab. Do they only use tools to create ML, machine learning models?
So our lab is interested in answering biological questions as well. So we use machine learning, we create models and try to use them rather than developing new ML methods or approaches. So, but the data is diverse, integrating is difficult. So we try to find out how to model using different data to answer our biological question. And also we collaborate with machine learning. We don't do it ourselves. We collaborate with, for example, in one project, we collaborated with Deniz Üret to develop such applications. Maybe Deniz wants to also talks about collaboration with different disciplines. I mean, AI and machine learning, especially, so interdisciplinary. The domains the problems are in other domains. At some point, might require collaboration.
Yeah, the only thing I would add to that is that sometimes the nature of the problem actually leads to innovation in machine learning. So, for example, in one of the latest studies we did with Atilla Hoca and Özlem Hoca, we had to use a 3D convolutional network in order to recognize protein-protein interaction regions. And at the time, this wasn't a very common application. So the nature of the problems that come from biology sometimes also leads to innovations on the machine learning side.
There is another question here for Professor Deniz Üret. It says, in the last video, the computer processes the descriptions, which is NLP, I guess, and designs a scene according to that, right? Where can I learn more about the subjects mentioned in the videos? Thanks in advance.
Right. So I guess the general field name can be said natural language understanding rather than natural language processing, because things like sentiment analysis, document classification, etc., only text-based technologies also fall under the topic of natural language processing. In natural language understanding, especially grounded language learning, grounded language understanding, there is many resources, workshops, conferences, data sets that people work on. If you send me a video, I can actually send me an email, sorry, I can give you some pointers to look at that. Also, if you go to my website, each one of the studies that I mentioned today are listed there with their papers and references, etc.
Thank you very much.
Thank you.
There's a very specific question. Which speech recognition data set do you use for Turkish? I don't know if that's for nearly all professors.
Yeah, maybe I can get in. Yeah, I mean, we do not specifically in our group collect Turkish data sets, but Turkish data sets especially for speech recognition are widely available through consortiums, and we reach them. In fact, actually, in our lab and university, we keep collecting data, multimedia data, audio, video, speech, in motion, especially in motion capture lab, which is really valuable to study the dynamics of interactions between pair of speakers, or maybe even between a group of speakers in communication scenarios.
Okay, thank you, Dr. Erzin. There's a question which asks, for a BS graduate, what are the differences between applying for an MS versus applying for a direct PhD? What's the difference in terms of workload, benefits, and trade-offs with respect to the research? So a direct PhD versus a master's.
So we should clarify that you can apply direct PhD without having a MS. This sometimes creates some confusion among students. They can apply direct PhD. We actually like to have a lot of PhDs on campus. In terms of the application, for PhDs, we require 3 reference letters as opposed to 2 reference letters for MS applications. If you receive the fellowship, the fellowship stipend is a little higher for PhD students. In terms of number of courses, etc., we follow YÖK rules, Higher Education Council in Turkey.
Also, can I add something? Also, it's possible to switch to PhD actually after 1 year of MS study. Yes. That's another path that you can take actually. And actually we encourage students, good students, of course, to do PhD instead of SCS. That's something we want, yeah.
I'd like to also add something. So master's being 2 years is usually quite short to complete a serious research topic and do several publications. So if your purpose is to go the academic route, we actually do favor direct PhD applicants. In addition, if you get your funding from other sources, there's some sources that basically favor PhDs. So for example, the 2232 program only funds PhDs. A lot of the Koç University's own funds are only designated for PhDs, etc. So it might actually also be easier to get funding if you do a direct PhD application, if that's the way you want to go.
Yeah, so don't think that you have to have a MS before you apply for a PhD. That's not a requirement.
Thank you very much. There's a question here. Are there any UAVs related projects like intelligent UAV navigation, etc.?
Fatma, maybe you can talk on this.
Not really. Barış, unfortunately, no. No. Like we have, some that's closest to mobile robots is the autonomous vehicle search. However, he's not affiliated with the lab, but there's a professor who likes to build drones from the mechanical side. I mean, if there's the right project, there would be, but currently there's an ongoing project with UAVs or drones.
Okay, there is a question, does switching masters to a PhD end in 5 years or 7? So if you switch your masters to a PhD, basically you walk away with all the coursework you've done for your masters. They get counted toward your PhD, so you don't lose years, actually. Correct me if I'm wrong.
No, I don't think
actually you get time. I mean, you so PhD sooner than, you know, when you do when you switch to PhD, everything becomes, you know, faster.
Things become faster. Okay.
You don't lose time. Yeah.
I would just like to jump in. I see some participants are using the raise hand feature. We're not using that feature today, so please type your questions, okay? There's a question here. Do you work on hand-body pose estimation problems and their applications on VR, AR, HCI?
I mean, we have a Karma lab that's specifically for AR and VR research, and we collaborate with the people at Karma lab. Like the existing MVGL lab at Koç also has some body pose tracking equipment. So there would be, I mean, projects. So we would be interested in it. I'm not aware of anything that's ongoing currently, but I'm sure if you also look at the Karma lab, spelled like with Karma, and you might want to get in touch with them personally, and then maybe come seek us again.
We work on VR and AR, but not on human tracking, like or human pose tracking. But we do work on VR and AR, like with applications in medical simulation, again, like human-robot interaction, and also some applications in haptics as well. So if you're interested, then you can contact me.
Okay, we have a question here. Maybe some professors can give their opinion. What are the most important programming language, or what is the most important programming language required for system software for AI? Perhaps for Professor Didem.
I'm sorry, so I was reading another question and I couldn't follow your question, sorry.
That's okay, I'll repeat. So what is the most important programming language required for system software for AI?
Okay, well, most frameworks, they have a Python interface, but if you look at their backend, they are implemented in C, C++, and CUDA. So we would like you to know C, C++ at least, but you learn CUDA here in my parallel computing course. So if you don't know, that's not a problem.
I'm going to, of course, plug Julia here.
Yes.
Julia is the only exception to what Didem said. So since Julia is a very efficient language and it directly compiles to GPUs without the use of CUDA, you can also look at that language as a possible system language for AI and ML.
So there is a question about TA-ship. I think we should answer that as well. Also fellowship plus TA-ship, may I answer, or anyone?
Sure, please go ahead.
So we would like all the students to do TA-ship. This is part of your education. So even you get the fellowship, you are going to do TA-ship. But that being said, most of the time, most courses will be assigned multiple TA-ships. So it's not a big workload. But there's also a question about if I don't get the fellowship, do I still have a chance? Sorry?
Very sorry, just one small note about TA-ship. TA-ship at Koç is 10 hours per week, whereas it's usually more in other universities. So you do it, but the workload isn't as much as you would go anyway.
Exactly. So TA-ship workload is not much, honestly. And there is also a question about if I don't get AI fellowship, can I get admitted to the program? Yes, you can. There are other funding sources, like we have a graduate student funding, we have TÜBİTAK projects, we have industry projects. The salary may not be as high as the AI fellowship, but if you're good and you are accepted to the program, there are other funding sources. And so TA-ship is not related to, attached to the source of funding, basically. I hope that answered the question about TA-ship and fellowship.
Okay.
Okay. I can do a question here. It's regarding the amyotrophic lateral sclerosis, ALS, as an unknown disease. They said to finding the genes that cause this disorder, protein architecture is the key to gene function. So protein-protein interaction can play an important role. So my question, is it possible to work on ALS at COSB lab with focus on protein-protein interaction?
Currently, we are not working on that disease, but why not? Of course, an expert for that disease might be involved in such a project, but currently we don't work. But protein interactions definitely plays a significant role there.
Okay, there is a question that asks about expectations from master's students. What should I accomplish by the end of my master's degree? What are the responsibilities of a master's student beyond taking courses? So I would say that really master's here at Koç is more like a mini PhD. It's very research oriented. So your first priority shouldn't be coursework. It should really be research. And as for expectation from a master's student, our expectation is that you generate a publication or two. That's the main expectation. Carry out novel research and generate papers.
And these, we should note that these papers can be in top tier journals or conferences in the area that you're working on.
Right, right.
We have a question here. I am interested in the development of autonomous robots for search and rescue applications. Can I know which professor might be interested in this field? So autonomous robots for...
Yeah, unfortunately, we don't have so.
Can you repeat the question, Melissa? I didn't hear it. There was an interruption.
Yeah, so somebody who is interested in the development of autonomous robots for search and rescue applications. I guess it's within the context of emergency situations.
As far as I know, no one here works on that topic.
Yeah.
Right.
It's an important topic, but yeah, we just don't work.
Sorry?
It's an important topic, but you know.
Yes, exactly. There's a question. I've already applied. Is it too late to be considered for the AI lab? And the additional question says, I see that your application deadline has passed. Is it too late to apply? The answer to both of these questions is no, it's not too late to apply. You can apply and you can still be considered for the AI lab.
So just to repeat, the application deadline right now is May 30th. And the AI Lab Fellowship application process is going to start after that.
Mm-hmm.
So there is a question here. Do you have any research about genome-wide analysis and high throughput data? So next generation sequencing data analysis.
And there are many groups and professors who use, especially in the medical school and molecular biology as well, high throughput sequencing. In our faculty also, we have a small machine that produces that data. We produce the data. But what the question is vague a little bit. There are research groups working with such data. But if the question is developing new methods to analyze such data, I don't think so. They are mostly users, let's say, of such analysis tools, if I understood correctly the question.
Okay. Okay, thank you very much, Attila Hoca. There is a question here. Is it possible to start the AI fellowship at the thesis phase of a master's in another university and then start the PhD in the next year at Koç University? I will get my master's degree at the end of this year, so should I wait for the next year to apply? I think the answer is yes, because you need to be enrolled as a student to benefit from the fellowship. But if Professor Denise wants to clarify, then please do.
No, I agree with your answer.
Okay.
We should also mention that our graduate program has two terms application, so spring and fall. So if you're graduating in the fall, you can apply in for the spring admission. So right now we are recruiting for fall admission.
Okay. I think we're coming close to the end of the time allotted for this webinar. Melissa, do you have closing remarks maybe?
I'm just trying to double check if there's any other research related questions.
So I think we will sift through the questions and answer them online. We will create a frequently asked questions page on the AI Lab website. So if there are any questions that were not answered here, you can find the answers online. You can email us as well if you don't get answers for your questions. Also, questions answered here will also be put on the AI Lab frequently asked questions page. So I think we are mostly done with the questions, yeah.
Yeah, we have here a specific question if there's any fund limitation to attend conferences such as CVPR, ICML.
Yes, there will be. So basically every student gets one conference based on the advice of their advisor. And after that, every time they actually have a paper accepted to one of the major conferences like the ones mentioned, we will support the travel as long as the travel restrictions due to Corona are lifted.
Right, so everyone wants to travel to these top conferences, make your way there by publishing there.
Okay, okay. So as Professor Metin was mentioning, we know that you have typed a lot of questions regarding to the eligibility of your current degree for the program, or whether you need to apply, do you need to contact the faculty members, or do you have to get a research proposal approved? All of this information is actually on the Graduate School of Sciences and Engineering website. I have written on the chat box of the webinar the link to that, the link to the YouTube video where that webinar can be found. If you want to, again, see more details about the AI Lab, specific projects that each of the professors are working on, the different groups, then please visit ai.ku.edu.tr. The group now has also an Instagram account, which we invite you to start following, and also a Twitter account. If you have questions about the application deadlines, requirements, minimum test scores, waiving test scores because of coronavirus situations, as Professor Denise mentioned earlier, please check the Graduate School of Sciences and Engineering website, which you can see there. It's gsse.ku.edu.tr. And they also have email details in there. If you're an international applicant joining us today, here are contact details for international admissions. We have a page called How to Apply, in which we have, again, put a lot of information regarding how to prepare a statement of purpose, how to contact professors in the right way so that you're more likely to get an answer, how to ask for recommendation letters. So there is a lot of guidance in that part as well. And as Professor explained, it's very useful to know your questions today to prepare a frequently asked questions sections for the AI Lab page as well, so that you will find all of those answers there. So we are going to now, let me see, yeah. So I'll go back to this slide so that you can, keep a note of the key website address, which I'll repeat is ai.ku.edu.tr. So I will kindly ask our professors to maybe, if you want to say any final remarks or anything you want to say before we close the webinar, to do that, okay?
I just want to thank everyone for coming, and I hope to get a chance to work with some of you next fall.
Yeah, thank you very much.
Yeah, thanks everybody for attending.
Thank you.
And hope to see you at fall.
Yeah, thank
you.
you.
Thank you. Bye-bye.
Thank you.
Stay
Thank you,
healthy.
everybody.
Stay safe.
Bye.
Bye.